Are you serious?
No. At least like you said it out loud. It's for my math.
I like it.
Okay. Morning, everybody. Happy Halloween. Halloween stuff here happen over the weekend, or is there Halloween stuff today? Over the weekend? Yeah. Involving fire extinguishers?
Yeah.
What?
I wasn't there, but apparently at Grips, there's a party and like people like stampeded like the barricade, and so campsite started spraying fire extinguishers out of it.
Interesting. I've never heard of fire extinguishers for crowd control.
It's actually quite dangerous to inhale all of that fire retardant material.
Yeah, I can see it being better than pepper spray or things, but I guess Scripps is also the college that I would have least guessed that we'd need crowd control at, like that.
They only gave out 200 wristbands to CMC, so everyone wanted to get it.
So it's the CMC who caused the riot.
Probably.
The CMC students are at least smart enough to forge the wristbands together, not to overrun the band.
Okay, so today in class, so there's a new folder 9 that we'll be going over, and the basic idea of the stuff that we're going over today, it's all stuff that you've seen before, encountered while you've been programming on your different projects. But we're going to talk about something called exceptions a little bit more formally, like all these big error messages that get barfed back up out of Python. And there's 2 files that we'll be looking at today, this exceptions.py and this exceptionscomplex.py. There's also, I've printed out this file for you. It's available in the back. And then there's this big, I don't know, 15-page or so PDF of practice problems for the quiz that you'll have related to exceptions. Again, the quiz about exceptions will not be this week. This week is going to be your beautiful soup quiz, integrating your knowledge of CSS selectors in Python. We'll have that quiz on Wednesday. And it will be beautiful. And then next week, you will have a quiz on all the stuff that we're talking about this week. Yeah, so this file right here, we're going to be going over it in class. The reason that I also provided you a printout is that it'll serve sort of as a cheat sheet for exceptions and be a handy thing to reference on the quiz itself. References for this week include these 4 links down here. There's a lot of information about exceptions, and yeah, so we're really only covering a very, very small fraction of the stuff that's in these links down here. Just some of the things that I've noticed that students this semester have been particularly encountering, and more broadly in previous semesters. Any questions about anything administrative? Timelines on things? Okay, and we'll switch over to VS Code over here, and we'll go over this exceptions.py file. So there are 9 exceptions that you'll be required to know for the next quiz. Technically, an exception in Python is anything that causes Python to print out that big error message. So currently I have a bunch of all the code in this file is commented out, put inside strings somehow like this. So when you run the file, then nothing bad happens. But if I were to say, we'll just start with this one up here, just uncomment these lines right here, and then we'll see that something bad will happen. Up arrow, rerun this, and this down here is an exception caused by the code above. And what we're going to be focusing on this week is how to better understand these error messages that get printed out by Python down here. And this will make understanding what's going on in your programs and why they're not working easier. Again, so there's 9 of these exceptions that you'll need to know for your quiz that you're responsible for. And each one has its own little header up here with examples about what causes those exceptions. So the very first one of these, I think, is pretty self-explanatory. This is a zero division error. And it happens whenever you divide by 0. So dividing by 0, not allowed with real numbers that you get like an infinite amount. 0 goes into 12 an infinite number of times. So no matter how you divide by 0, there's a lot of different ways of doing division in Python. No matter how you do it, you get this zero division error down here. You know what the exception is that you're getting because it'll print it out on the very last line down here. This thing to the left of the colon is the actual name of the exception right here. And then to the right of the colon over here is some sort of explanation about the problem. Question?
For the actual quiz, what do you want us to know about these? Because we know there are errors, but what would you like us to specifically and explicitly say?
Yeah, so the question is related to the quiz. What do you have to specifically know? We're going to talk about this exception in detail a little bit more, all the different stuff that's going on down here. And then we'll get to, in like 5 or 10 minutes, exactly how to translate that to the quiz. So, good question, but hold on to it just for a second. Good question. Any other questions so far? Okay, so again, reading this error message down here, this very last line is always the most important line. It's always divided into 2 parts. To the left of the colon over here is the name of the exception. We say this is the exception that got thrown or the exception that got raised by the offending line of code. And then to the right of the colon is an English language description of what's going on. In order to figure out what line the exception is actually happening on, you always start at the bottom and read, go up until you find your Python file. So here is my particular Python file. And then it tells us the particular line number right here, and it prints out the contents of that line in order to make it a little bit easier to find. So this division by 0 error is happening here on line 8. And so we're never even getting, for example, to line 9. Whenever an exception happens, Python immediately pauses, immediately stops execution of the code, and doesn't do anything else. If I print hello world right there, Python will never get to that and it'll never run hello world. And all of these lines cause a similar zero division error exception to be raised. And so if I were to comment out, for example, line 8 right here, then this line 8 will no longer raise this exception. And if I rerun this, we'll see that the exception is now being raised on line 9, being dividing by 0.0 instead of 0. And so again, there's these 4 different ways of doing division-like things in Python. And so there are these 4 different ways of causing this particular exception. For the quiz, what you'll have to be able to do is, let me, I'll pull up the PDF here in a second, but well, no, I'll just go pull up the PDF right now. And I forgot to open it first, so it'll take this. Okay, for the quiz, the format of the quiz now is a little bit more complicated than the formats of the previous quizzes. That now I'm asking you 2 specific things about each piece of code. The first one is up at the top, whether something is going like a piece of code down here, whether it's going to terminate without error, whether it's going to throw an exception, or whether it's going to run forever. The only time that things will run forever is if you have a while loop where the condition of the while loop is always true. And so this is very rarely going to happen. If you don't see while anywhere, you can just cross that out if you know that that's definitely not going to happen. When we see throws an exception, that would mean that Python somehow barfs out an error message like this. And if Python does barf out an error message like this, then you are responsible for actually telling me exactly what that error message is, what that exception is. You don't have to write out this entire trace back. You don't have to write out this entire output of Python, but you need to be able to write the thing to the left of this colon. What is the actual cause of the problem? And if something, if there is no exception raised, if it terminates without error, then it's just like our previous quizzes where you just write the actual output of the code, whatever gets printed. Yeah, so the once we see some more of these exceptions and what they do, then we can revisit the quiz and see and work some of those problems. But we'll have to see more of these example error messages first. Okay, that's the high level idea of how you'll be graded on this knowledge. So that's the first exception, zero division error, relatively simple one to identify and fix when you encounter it. The next error is the attribute error. And this happens whenever you have something that looks like this period. The thing to the right of this period is again called an attribute. So here in this syntax right here, function is an attribute of object. And this down here, replace is an attribute of XS, append is an attribute of S. And so if that attribute does not exist for some reason, then that will cause the error. So let's go ahead and comment out these lines right here, or uncomment those lines. We'll save that, come down here, up arrow, rerun it. And we get this attribute error. The list object has no attribute replace. Looking on line 20 right here, line 20. So maybe the thing that I was trying to do was to find all of the 2s and replace them with 3s. Well, replace just doesn't exist. It's not a thing inside of lists. So we get this error message. A very common cause of this, I've seen this many, many times this semester and past semesters, is when you use list operations on strings. So recall that append is something that exists on a list. Lists are mutable. You're allowed to change the values of lists. So you're allowed to append to a list. Strings are immutable. And so attributes, these functions that exist to the right of the dot, an attribute can never change the value of a string. And so these functions like append that exist on lists can't exist on strings. And so this will give us an attribute error saying that the string object has no attribute append. So as you're working through your own code, trying to figure out why things are or are not working, and as you're working through the quiz, it's very important that every variable, you know exactly what the type is of that variable. You know whether it is a string or a list or whatever the type is, so that you know what these attributes, what the valid attributes are that you can apply to it. Any questions about the attribute error?
For
Yes.
the line where it's whenever the object dot function, if you were to go a bit more to the right, does that just say is not applicable for object? It's in the code, you commented that whenever the object dot.
What line are you looking at?
Line 17.
17.
Yeah.
Syntax used, but dot function.
Just curious with the last word. Thank you.
Yes. And this is all you have the printout for this file, so that you'll be able to use it on the quiz and reference exactly what are the prototypical causes of all of these errors. Yes.
So I'm assuming like for like a dot find, for example, people use that for a string, but for a list, or is it different?
So the question is that we've seen this dot find function before. Does find exist on strings and lists? So let's try s dot find of h. This is something that we have seen before. If we run that, then no exceptions. If we do xs dot find of 1 like that, run that, and the list object has no attribute find. This is an example of a function or an attribute that exists only for strings, and append is an example of an attribute that exists only for lists. There are many of these attributes for any particular type, and the cheat sheet that you have lists a large number of them for strings and lists. On your quiz, I'm only going to ask you, I'll only use functions that are found in the cheat sheets. Good question. Any other questions so far?
I might have just missed this, but we don't need to know what comes to the right of the colon when writing it down on the quiz.
Question is, do you need to know what comes to the right of the colon on the quiz? And the answer is no. All you need to know is to the left of the colon. And in general, when I'm like working on things, like this is always the exact first place that I look whenever I see one of these tracebacks get barfed out by Python. This is like the most informative single word on this entire thing. And so this is always the first place to look. Good question. Any other questions so far? Yes.
So when you have it uncommented, the XS and then the S, they have the like red squiggle underneath. So does that indicate that there's going to be an error?
Yeah, so VS Code helpfully tries to identify all the different errors for you. It's not perfect, but it's pretty good. And so here we get the red squiggle underneath, which is an error message instead of a warning, which would be the yellow squiggle. And if we hover over this, you'll see that it'll tell us exactly why it thinks there's an error here. That instance of list has no replace member. One of the things that it does not tell us, though, is what is the actual like exception that's going to get raised. So this is useful like when debugging. Usually it's just like, I don't know, the way that I would think about it is that if I see like red squiggles, then I just know that something's wrong. But I guess personally, I find these messages down here more helpful than these ones up here. But for the purpose of the quiz, you don't need to know like anything about what VS Code tells you up here. Good questions. Okay. The next exception is the index error. Probably everybody has encountered this at some point, but it's whenever you're using the square bracket indexing notation, also called the subscripting notation, and you pass a value that is out of bounds for a list. So here, XS is a list up here. We have XS at position 3 right here. Well, this list has 3 elements, but the very last index is position 2, not position 3, because everybody knows that 0 is the first number, not 1. And so when I run this code up here, I'm going to get this index error telling me that the list index is out of range up here. You'll notice that so I'm going to modify this code here. Let's try using a slice like that. So the only thing I did was I added this colon to make this not an index, but a slice. And I save that down here, up arrow, rerun, no exceptions. If you're using a slice, you will never get an index error when you're using a slice. So if using a slice, which means there's a colon in the square brackets, colon inside the square brackets, never get index error. That's a very common mistake on the quiz, and also just a common thing to be confused about when programming. Question.
So if you put, say it was 5 slice 0, or like 5 slice, like what would that?
Nothing. What this says, give me all the elements in this list starting at position 5, going to position 0, and there happens to be no elements in this list starting at position 5, going to position 0. So if we stored that in, say, a variable y, and then print y equals y, the way we know this slice just doesn't contain anything is that the variable y itself will be the empty list. So yeah, you instead of actually getting an error here, we're going to get this, we're just going to get an empty list as the results.
And what if it was 0:5? Without anything else?
And so now 0:5 like that. Now we'll just get the full list, even though this is bigger than the end of the list. It's just not going to give us those extra values. If we so back to a indexing operation instead of a slicing operation, so no quotation marks. We said that 3 threw an error message. Let's try -3 right here. Run that. You see -3 does not give us an error message because -1, -2, -3. This position does exist inside the list. But if I try -4 down here like that, I still get the index error, list index out of range. So if I have the put in the wrong index up here, if it's too big or too small, either way out of bounds, I'm still getting that same index error. Any other questions about the index error? Yes. Yeah, so the question is why does this not raise index error? There's a couple of different levels to answer this. The most immediate answer to why does this not raise an index error is because Guido van Rossum, the benevolent dictator for life of Python, believes this should not raise an index error. And because he said so, that's the way everything is. That sort of begs the question about okay, so why does Guido think that way? And the answer is that, well, there's a couple of different levels of this answer. One is that in Python with lists, there's a very natural version of the empty list of how you identify that something somehow failed. And that's just the empty list. But if you're doing an indexing, there's maybe not quite as natural of a way to identify that the indexing operation failed without actually raising an error. You might, I don't know, think that, okay, maybe excess of -4, this could evaluate to none instead of raising an index error, but you can actually have the value none inside of a list. And so then there's no way to actually tell if this had an error or not, if it was out of range or not. But with slices, you can always tell if your slice didn't work just by checking if it's the empty list. So that's sort of the philosophical justification that people use these days. The actual reason about why this is the way that it is because Guido sort of list was one of the first things that Guido implemented in Python over 20 years ago. And he basically just did it over the weekend and said, okay, this seems reasonable at the time. And now all code that uses Python expects things to behave this way. And so even if there was a really good, slices, we really think they should throw an index error, it's impossible to change at this point because there's billions of lines of code of Python and they expect slices to behave that way. And so even if they shouldn't behave that way, they have to behave that way for existing code to keep working. So the takeaway is that it's just a little bit confusing and you have to remember that slices will never throw an index error. Good questions. Yeah, so this is the first one that's a little bit confusing. And the next one, this key error will just add to the confusion about the indexing notation here a little bit. That, again, for whatever reason, when you're using a list and you have something that is out of range of the list, the index error is what gets raised. But if you're using a dictionary and you have a key that is not in the dictionary, you get a key error raised instead of an index error. So here, like this is the same sort of notation here, the same square bracket notation, the same subscripting notation. But now instead of getting an index error, I'm going to get a key error that's raised instead of the index error. The only way that I'm going to know that it's a key error that's going to be raised is the fact that this is a dictionary up here defined with the curly braces. Again, like, why do we have two separate error messages? It seems like we could easily use just one error message and there's sort of no loss of information. And the answer, again, is just that this is what Guido thought was the most natural thing when he was first implementing Python. And so that's how things work.
So there will be two different errors for when it's out of bounds versus when it's like just doesn't exist in the dictionary.
So so there's two different errors: index error, key error. Index error happens when you have an index that's not valid for whatever reason on a list. Key error happens when you're using this and it's not valid for whatever reason on a dictionary. Whatever the reason is that it's not valid, doesn't matter. It's just key error, dictionary, index error list. I'm not sure if that answered your question.
I think I asked it poorly. Like if the key just doesn't exist within the dictionary at all, versus like when it's just out of bounds for what you're looking at.
I'm not sure what you mean of out of bounds for a dictionary.
When for line 41, when it says is out of bounds.
Okay. So by out of bounds here, that's a synonym for doesn't exist. There's no difference between doesn't exist and out of bounds. That it's just synonyms for each other. Any other questions about difference between index error, key error? So yeah, if here we had created _at, then no error message. Again, this is all case sensitive. So if we have like capital created at, that's not going to work. Still give us our error message. So mixing up the key error and the index error, very common way to lose points on the quiz. And guaranteed there's going to be at least one problem involving the key error, index error distinction. And the way the grading on the quiz is going to work is that you have to get 100% of the problem correct in order to get any credit on the problem. So even if you identify that it does throw an exception, so that it does raise you realize there's a problem with this code right here, you realize there's a problem right here, but you say index error instead of key error, you'll get zero points on the problem. So you have to get the exact exception in order to get credit for the problem. Okay, next errors. I think these ones are the most confusing of the error messages. And so let's take a look at them. So I'll do just uncommenting them one at a time, going down the list here. So here we have this just random word example thrown in here, and I've not defined this example anywhere. And so down here, up arrow, rerun this code, I get a name error. A name error happens anytime you have some particular string that is not defined. And so again, the information to the right over here helpfully tells us exactly which word up here is not defined. In this case, there's only one thing here that's not defined. But maybe, yeah, I could have like, I don't know, x equals math dot square root plus example like this. And that takes an argument. And down here, it'll still tell me like, okay, in this big long line up here, what is the exact word that's not defined? It tells you to the right of the colon over here. So anytime you see name error, the thing in quotation marks is the thing that's actually not defined. For the purposes of the quiz, you just need to know like that it's going to give you a name error though. Question?
I know it says name error slash unbound. If we use the wrong, is it this?
We'll get to that. So yeah, so here's an example of the name error. One of the most common ways I see this happen for students is involving dictionaries, something like this, where you have the like this text right here exactly matches this, and so you think that this D at square bracket text is going to be getting this particular key right here and this return this particular value. But this right here is not a string literal. A string literal is something contained inside of the quotation marks. This is what Python is interpreting this as a Python variable. And so this text right here does not match this up here. Python tries to interpret this text as a variable, says, I don't know of any variables named text. And so it throws this name error down here. So this is another like very confusing spot on the quiz where people will miss points. Is I'll do something like maybe it'll change this to created at up here like this. People look at D at position text, say, hey, there's no text key inside of this dictionary. I know that that's going to raise an error. And since it's a dictionary, it will be a key error. But that is not the case because this text is a variable. And so we'll get the name error down here, not the key error. Name error down here because text is a variable and there is no variable actually defined to be text. I can make this a little bit, make this actually work by saying text equals created at like that. And now down here, this text variable, Python will substitute in the word created at down here. And that does in fact match this key right here. And so this will in fact give me the hello world result down here. Save that down here, up arrow, rerun, no exceptions caused here. So this variations on this short 3-line thing of code, very, very easy to make mistakes on the quiz. Any questions about that? Okay. Let's comment this back out. And so now back to, there's the question earlier about the name error versus the unbound local error. Everything that we've seen so far has been a name error. And what's the deal with this unbound local error? For various complicated internal reasons, and also, again, just because Guido says so, if you're inside of a function, then, and you have what would normally be a name error, you can get an unbound local error. So here we have new example plus equals 1. New example right here has not previously been defined anywhere. So if I we'll start with new example plus equals 1 up here. This is not inside of a function. And again, this is entirely equal to new example equals new example plus 1. This plus equals is just syntactic sugar for this thing down here. And we're defining it right here, but this thing on the right doesn't exist yet. So we're getting this error message. Save that, come down here, up arrow, rerun, and we get name error, new example is not defined. Line 62 right here, name error because this is not defined and it is outside of a function. Okay. Is that? Comment that back out here and come down here. So this line 64 to 67 is the original code that I have, the thing that matches your printout. Come down here, up arrow, rerun, and now you see that it says unbound local error instead of name error. So unbound local error can only happen inside functions. Unbound local error, it's like name error, but inside functions. One of the common ways to make a mistake on this, well, let's see, before the common mistakes, it turns out that unbound local error is not the only error that can happen inside functions. Sometimes you can get a name error inside functions. So if I have just the word example like that, save that, come down here, up arrow, rerun. Then example line 65 gives us a name error. New example down here gives me the unbound local error. Unbound local error. The reasons why you might get one or the other, the differences between the two are subtle, and you're not responsible for knowing those differences. So for the purposes of the quiz, then you can treat name error and unbound local error as synonyms. And that's fine. You can just put name error anytime something is not defined. For the purposes of like your actual like coding and debugging things, you'll have to be able to recognize though that if you see something that says unbound local error down here, that it's the same cause as a name error, that this thing over here is not defined. Did that answer your question, Jackson? From any other questions? Yes. Yeah, great question. So the question is, what if we have a problem that has multiple errors in it? So it's easy to generate something that has multiple errors in it for us right here just by doing this, and we'll say text like that. So up here, we're going to have somebody shout it out. What error message is going to appear up here?
Key error.
Key error, yeah. And then down here, we just saw it's going to be the unbound local error. And Python, as soon as it hits one of these exceptions and barfs out this big error message down here, Python stops execution. And so if your quiz problem looks like this, both of these things together, you would ignore the fact that there's an error down here because we're never going to get to that line, and just tell me that you're going to get a key error. You don't have to tell me which line is going to cause the key error, but just writing key error would be fine, and you don't mention this error down here. Did that answer your question? Go ahead.
Could you use an except, for example?
Pause that. We'll get to it later. Okay. Yep.
I may have missed this, but does the function even call?
Fantastic question. So let's comment this out down here. And so the question is, what happens if we don't actually call the function? So this again here is a tricky way of not calling the function, because in order to actually call a function, you have to put parentheses next to it. If you just have the name of a function like this, but no parentheses, Python is okay with that. It just doesn't execute the function. So if we save that, come down here, up arrow, rerun, no error message right here. The reason we're getting no error message is because when we define the foo function like this, then Python does not go inside of this and actually run these lines of code. It just saves this inside of its memory somewhere, so that later on when somebody does run this, it's going to then when it actually gets run, that's when it will encounter the the problem here and raise this exception. So there's a very common way for students to lose points on the quiz again, is that if you define a function, just because there's an error in that function doesn't mean an exception is going to get thrown. The exception will only get thrown if you actually call that function. And there's this tricky way down here that you have to be able to recognize that this does not in fact call this foo function.
So I guess in other words, say that from line 64 to 67, but it was def foo, and then it was, you didn't actually call foo, there wouldn't be an error there, so that would not throw. But then if you had another error after that line 68, for example, like maybe a key error, then you would only have the key error afterwards.
Yep. So yeah, let's just do, yeah, something like this. So this, when we define the function, no, we don't go inside, even though VS Code is telling us there's a problem right here. We're not actually running line 65 ever. And so down here, we get a problem on line 68 with this key error. If I were to eventually call the function like this on line 69, then Python is going to stop execution on line 68 right here because of this key error. And so we will never get to the unbound local error caused by the foo function here on line 69. We'll never get to this error message down here. You always have to identify the first one. And this is a confusing case because the actual line here that causes the error comes before the actual first error message down here. And so you have to recognize that. All fantastic questions so far. Any other questions? Okay. Okay. All of the, let's see, so the previous error messages get confusing in the way that they interact with each other, but they all sort of have exactly one thing that causes them. So in the sense of like what causes the error message, it's not confusing. What's confusing is like, is it a key or an index error, or just like which one is actually happening at any given location. The type error gets confusing because there are many, many, many different ways to actually cause a type error to happen. So I've listed some of these down here. These are the only ones that you'll be responsible for on the quiz, but there are many other ways that you might encounter in real life. So this first one is that you have math operations that you're using when you're not allowed to. So let's do like this. Here, if I say my age is and then plus 35, well, I mean, like I understand what we're trying to do here. We're trying to make a string that says my age is 35, but you can't add strings and lists together, or sorry, strings and integers together in Python. And so you get this type error. The stuff to the right of the colon tries to explain to you like what it is that you're doing wrong. You can't convert int object to string implicitly, that this is the int object to the right of the plus, and it's trying to convert it to a string in order to make this addition happen, but you can't do that implicitly. Implicitly means without like actually describing what's going on. If you wanted this to actually work, you would have to explicitly convert this number into a string. Now for this math operation right here, the thing to the right and the thing to the left are both strings. You can add strings to strings, and so no problem right there.
What's the reason when you're floating to write for string concatenation to write str versus just putting it into quotes?
So yeah, the question is, why did I use str when I could have just done something like that? If I knew, for example, like that it was exactly going to be 35, then, well, I would just make the string like exactly like that. With str, this is sort of generic in that I can pass any variable that I want to it. And down here, if I have x equals 35 or whatever else that thing might be, it'll convert that variable into a list, or sorry, into a string. One of the things that students commonly make a mistake with is if you do something like this, this is going to, set that and print s equals s like that down here, run this. It'll print out my age is X, that this is the like literal string X, and it doesn't do the variable substitution inside of the string at all. So if you actually want to convert something to a string, you have to use this str function like this. Yeah, you don't get an error message, you don't get an exception when you do, whoa, where did I go? This doesn't cause an exception, but this just doesn't do what you probably wanted it to actually do. So the original question was, why did I use the string function here instead of just putting it in quotation marks? And the answer is that the string will work no matter what value you have inside of here. Good question. Any other questions so far? Yeah.
When you're adding none plus the passage of string for the num value, how would you fix that?
Okay, so here we have none plus test, up arrow, run that. So unsupported operand types for plus, none type and string. The thing to the left is this none type. The thing to the right is this test. This commonly, the way that a lot of students have encountered this is on your Markdown compiler. People commonly got this type error. And what often happened was that you had a function somewhere, and your function had a lot of different processing things that it did. Like, I don't know, if I'm not going to write out an entire function that you had from length of s is greater than 10, return hello. If length of s greater than 5, return goodbye. So this is just a very simple function right here for your Markdown compiler. You were somehow like adding HTML inside of this string in various situations. And most of the time, the return value of foo right here is going to be a string. And so if I change this to like foo of hello world, here's a string right here. It's relatively long. And so this will get substituted for the value of hello, s equals that, print s equals s, like that. Save that down here, up arrow, run. And so we get hello test, the return value of this function right here. What this function gets evaluated to, the type of the return value is a string. And it makes sense to add a string and a string. But if whatever I pass to this foo value is like really short, then I'm not going inside this if statement here. So I'm not returning hello. I'm not going inside this if statement right here. So I'm returning goodbye. And so I'm going to hit the end of this function without returning anything. So this is going to evaluate to none right here. And so we get this type error, unsupported operands for plus, none type, and string. This, again, like 99% of the time that you get a type error that contains none inside of it, it's because you have a function somewhere that is returning none when you thought it was returning something of a different type. And so the way to fix what the original problem looked like was none plus test. The way to fix this error by finding the source of none that you probably were not intending for that thing over here on the left to be equal to none, and figure out why it is none and fix it so that it's not none anymore. Did that answer your question? Good questions. Last of these examples. This looks like something that you might want to do in order to append the number 4 over here to this list. But in Python, if you want to append to a list, then you have to use that append function. Plus, it's okay to add strings together. That is acceptable. You can add strings together. That does in fact append this string on the right to this string on the left, but you cannot add non-lists to lists. That is unacceptable. So there are many different combinations of mathematical operations that you cannot do together, and you are responsible for all possible like combinations, knowing that. So there are a couple of things though that are maybe surprising about what you can do. We've seen all these examples before, but now's a good time to remind us of that. The first one is that here with this addition, I have two different types here for addition. The thing on the left is an integer. The thing on the right here is a float. This is allowed in Python. This will not give an error message. This does the, again, what's called the implicit conversion of this integer over here into a floating point number. And so that works. This down here, you're allowed to take a string and multiply it by an integer. This, what it does is it just repeats that string 40 times, Python 3, x times 40, repeats the thing to the left 40 times, hello times 10, repeats the thing to the left 10 times. Most people think that this is like a really ugly thing about Python that allows you to do this, that very, very rarely is this something you want to do. But again, like 25 years ago, Guido thought this was a cool thing, and so now we're stuck with it. But most people would prefer that this throws an error message. If you multiply by something that is not an integer, so like x times 40.0, then you'll get this type error because the thing on the right must be an integer. Even though this is kind of an integer, because like in mathematical real world, 40.0 is equal to 40. In Python computer world, this is a different type than integer. It's the float type, and so that doesn't work. These are the only two situations, at least of things that we've seen in this class, where if you have a math operation, the thing on the left and the thing on the right can be of different types. Otherwise, if the things are different types, then you'll get that type error. Any questions about those? Okay, another common thing that happens to students is you use the length function. Length is supposed to give you the length of a container. So something like a string or a list or a dictionary. But if you pass something that is not any of those things, then you'll get the type error. So leave interactive Python, up arrow, rerun this. Type arrow, object of type int, has no length. This is not a container up here, so it has no length. If I said something like x equals a dictionary up here, no problems with that. The length of this dictionary is just 0. It has no elements in it. If I said list, no problem. If I said string, no problem. All of those things are somehow containers that contain things inside of it. And so it makes sense to talk about the length of those, makes sense to talk about the size of those. But it doesn't make sense to talk about the length of an integer. And so you get that type error. So again, one of the things that's confusing about the type error is there's so many causes of it. Now we're gonna see how type errors can be confused with index errors and key errors. So up here, if we have something that is not a container and we do the subscripting operation, that will give us a type error. So int object is not subscriptable. Anytime you see this subscriptable, talking about subscripts, it's referring to the square brackets like this. So int is not subscriptable. Lists are subscriptable. That will not throw an error. Here, if we change this to be like out of bounds, then we get the index error because this is a list up here. This might, I don't know, may seem like it's out of bounds down here, but we can't even get to the fact that it's out of bounds because this thing to the left on here is a is not a list, and so it doesn't even make sense to talk about like what are the boundaries of, or what are the possible allowed values here. So we get the type error. The next one down here. So here now we have a list, but instead of passing an integer index down here, I'm passing a string down here, this test string. So I get type error instead of index error. So if I passed a 5 here, I'd get the index error. Pass anything that is not an integer, I get the type error. 5.0 type error. It might seem like 0.0 makes sense right here, that if it was not 0.0, if it was just 0, that would give me the 1 up here. But because it's 0.0, it's not an integer, and this gives me the type error. So anytime you see the square brackets, there's 3 potential causes. It's either an index error or a key error or a type error, and it's very easy to get confused about which of those 3 it is. Any questions about which one of those 3 it might be, or anything that we've seen?
It would make sense to not work. If you had, say, a float value and put slice at the end of it, it's still type error.
Yeah, good question. What if we talk about slices like this, up arrow, still the type error? Now it's a slightly different error message over here to the right, but it's still the type error about you can only slice with integers. Similarly, if we had like a string like that and try to do it, we'll get this type error that slices require integers. Another common mistake is you have a function and you have something that's not a function, but you put the parentheses around it like this. And that is going to give you a type error saying the int is not callable. X here is an integer, it's not a function, so it's not callable. I actually personally encounter this error all the time because I often, like, I know when I'm writing out math equations, just like by hand on paper, you'd put 2 numbers next to each other to do multiplication, or you put a number in front of a parenthesis to indicate that it's like this number times that thing. But that gives me a type error because, oh yeah, in Python, that means calling a function. And if you want to do the multiplication, you actually need the multiplication star symbol right there. So that's the first example. The second example down here. But up here, so we're correctly defining a function, returning 5, calling that function right here. And down here, when I say foo equals 5, that's overwriting the previous definition of this function, setting it just to be a number like that, and then trying to call the number right here. So save that, come down here, up arrow, rerun. Int object is not callable. That line 137 works just fine. Line 137 works just fine. No error message, line 137, we execute that fine. But line 139, we replace what foo means. It's no longer a function. It's now something else, and that's not callable. This very commonly happens to people when you do something like, okay, I have a list, xs equals 1, 2, 3. I want to somehow remember what is the length of this list. And I don't know, a very natural variable to remember the length of something is length like this. But now length is no longer a function. Length is just a number. Print length equals length right here. Come down here, up arrow, rerun it. And so there's an error on line 147, error on line 147 right here. Like this length function worked totally fine, was correctly able to print the length right here. But because I overwrote what that length function means right here, I can no longer use the length function. And so this throws an error right here. So just because something like this works at one point in the code doesn't mean it's going to continue working at other points in the code.
But if you put if you made line 145 after the equal sign, you put string before, right? So like right there, that's the
And down here, up arrow rerun, still a problem. But what like that, the fundamental source of this problem is that over here to the left of the equal sign, I'm saying that length, I don't care what it used to be equal to. I don't care that it used to be a function. I'm setting it equal to something new over here. This thing over here is not a function. And so we're getting this error because down here, like whatever the thing on the right is over here, it's not a function anymore. So we can't treat it like a function down here. The way to fix this is to change the name of the variable, like length. And now down here, length, save that, down here, up arrow run. And now there's no problem. Now down here, I can do this correctly because I did not overwrite the value of this function. See this mistake? Yeah, very, very common mistake with students, especially as we get into the last few projects that we have. That the previous projects, they might not have felt small to you necessarily, that some of them had hundreds of lines of code in them. But the upcoming projects are going to have thousands of lines of code in them. And so it's very easy for you to like just forget the fact that you're using the same name in multiple spots to mean different things. Okay, number 5, so many causes of this type error. Like if you know there's an error and you just can't figure out what it is, I guess this is the one to guess because so many causes of it. So now we have that a function is called with the wrong number of arguments. So this length function again is our example. Here, if we have length with nothing passed inside of it, this makes no sense. That's the length, you're supposed to like pass a container to it somehow. And so run that, type error length takes exactly 1 argument, but 0 were given. So we've seen a couple of different sources of errors for the length function. One was that if it's not a container that we pass inside of it like this, that's going to, hey, it's also a type error. If we pass in the wrong number of arguments, then it's still a type error, different information out over here to the right-hand side of the colon, but you're not responsible for that. Just type error is the thing to know. And so here we have too few arguments. The next example is too many arguments, trying to somehow take the length of 2 lists at once. What does that even mean? It's going to give me this type error length takes exactly 1 argument, but 2 are given. All of my examples here happen to use the length function, but any function in Python will give you the same error message. I accidentally actually caused this error message a little bit ago and didn't remark on it, but when I called the square function, square root with nothing inside of it, like this, then I got this type error saying the square root takes exactly 1 argument, but 0 were given. And so you always have to pass something to that. Any questions about any of these different causes? Yes.
Did want to take the length of 2 different lists, which seems kind of a common thing. Instead of having to assign 2 different variables to that, is there a function that you can do that?
Question is it possible to take the length of multiple things at the same time with a single function? And the answer is no, that you always have to, the way to fix this is something like xs length equals length of xs and ys length equals length of ys. You have to do it separately. Okay. So we've seen a lot of, I think, complicated exceptions at this point, and now we're going to get back into some that are simple to understand, like what's causing them. If there's anything complicated about them, it's just like, why does it even exist? But this is a common one that you'll see, and so you'll need to know what it does. And it's a really simple one too. At least it's really simple to figure out whether it throws an exception or not. If you see the word assert here, assert is a special built-in function to Python, and it raises the assertion error whenever the thing inside of parentheses is falsy somehow. And so again, false is the prototypical example of something falsy. If you have an expression that evaluates to false, that'll also raise the assertion error. Or if you have just some element over here that would be falsely inside of an if statement. All of these things raise the assert error. Maybe the question is like, okay, why would you ever use this assert function if it's just going to make Python immediately crash and stop? The answer is that it's useful for like debugging purposes, for making sure that your function is called with correct values. So down here, I have a function that's called maximum value. Again, the doc string up here tells me what it does. It computes the maximum value of the list of XS passed in here. And if there is nothing inside of this list, then like what is the maximum of the that? That just doesn't really make sense. So we need to throw an error somehow. So we raise an error. And the assert function is the common way to just check that the inputs to your functions are sane, are reasonable. And so if you see assert in practice, it's always at the very top of a function, just checking to make sure that whatever the conditions of the function are, they are met. We save that, come down here, up arrow rerun. No error message possible because we never call this maximum value function. If I call maximum value with a 1, 2, 3, something like that, here is a list, and the length of that list is greater than 0. So the assert is not going to get triggered. This assertion is not going to get triggered, and there are no error messages here. If I call maximum value with an empty list like that, then come down here, up arrow rerun, we get this assertion error right here. Yes.
Say a function where it's like if x is greater than 3, return yes, and then else assert. That's still a truthy. It's a truthy thing that will then evaluate the assert, which then will be falsy. Or that makes any sense?
Anytime you have assert, you must pass something here to assert to trigger it. So you could pass just assert false. A common thing that people like do, so assert false will raise the assertion exception. That's not really something that people do in practice. Something that people do in practice is something like this should never happen. And this is a truthy statement right here. So actually this we'll need something like that to make it falsy, and then this will panic immediately, and the error message down here, since it prints the line, will actually print out like this should never happen. Yes.
Why would someone use the assert function instead of just using like an if statement, an if else statement?
Yeah, so assert can be used this way. Next thing that we're going to see is a better alternative to asserting like this. Assert, the way it's actually used is that you put the asserts at the very top of your function, and you just assert whatever the conditions are that your function assumes must be true before that it runs like this. See, good questions. Let's see a couple more variations on this. Let's just go ahead and check, make sure. Okay, so we're getting an assert. Let's take away this assertion error right here, up arrow rerun. Okay, no errors like this. Let's see what happens if I do maximum value like this. No strings passed inside here at all. Save that. Come down here, up arrow rerun. I get the type error because maximum value, like I never even get to call this assert function right here, because I never get to call the maximum value function, because as soon as it realizes that there's not the right number of arguments, that maximum value is supposed to take exactly one argument, but there are no arguments inside of here. It immediately panics, never gets to this line right here. So this will be the assertion error. This right here will give me the type error. If I try maximum value, and now let's pass in something like the number 6, like this. What's going to happen? Well, I'm not going to get the type error from the wrong number of arguments. This 6 will be passed into XS. XS here will be substituted as 6, and then it'll take the length of the number 6. That length of the number 6 does not make sense, and so we'll get a type error saying object of type int has no length. Just looking at this line right up here, it's kind of difficult to figure out, like, okay, like, I don't know, this looks reasonable right here. I know XS is supposed to be containers somehow. But since XS is the only variable right here that's inside of length, somehow XS must be an integer. And I have to like think about back out, okay, whatever got passed into here must have been an integer somehow. And see, oh yeah, I got an integer right here. The type of this and it has to be a container, something that I can reasonably take a maximum over. And now it'll work. So this will give me a type error, but for different reasons than the fact that that one gave me a type error up there. Any questions about any of those 3? Yes. When you have assert what? Question is, if we have assert just like this, nothing passed inside, what happens? And that will give you an assertion error, not a type error. Assert is a special built-in thing to Python. I can't imagine. I've never seen anybody try to do something like this in practice. This is line 185, will not appear on the quiz. If you have assert, it will have something inside of it. It does not guarantee an assertion error because this thing over here could be true, or there could be an error when evaluating the thing inside of it, but it will have something inside of it. Good question. Okay. Last thing that can appear on the quiz is this value error. And a value error is sort of like a generic catch-all error message that just somehow says that a bad value is passed into a function. So if we have this square root function, square root is not defined on negative numbers. And so we get this value error. And then it has this, I don't know, this is helpful for me, math domain error. Like I know that the domain of the squirt function square root must be non-negative, but it's not necessarily super helpful. In general, like if at all possible, when you're writing your code and you're creating errors, you want to avoid the value, just value error, because it's very uninformative about what's going on. Other causes of the value error are, so here the int function, this line right here is going to work, but these other lines down here are not going to work. That the int function, come down here to interactive Python, if I do int of say 5.5, that'll truncate this, convert it into an integer somehow. It's okay to convert floating point numbers to integers. It is not okay in Python to convert random strings into integers. It doesn't know how to convert this thing into an integer. And even if that string like actually contains a reasonable sort of number like this, that will not work. It won't. But if it actually contains an integer, that will work. So valid int of 2, and then raises value error int of 2.3 in test. There are many, many causes of value error in Python. The only ones that you're responsible for are the square root function, negative numbers, and the int here on things that do not work for integers. The one last thing for us to talk about today, we'll get this here. This is this maximum value 2 is the same function that we had before. It just has a different method up here of checking whether our conditions are successful or not. That we have a regular if statement up here, and then we use this raise keyword here to actually raise and trigger the error message. If we ever get to line 222, so maximum val underscore value 2 of the empty list, write that, come down here, exit interactive Python, up arrow, rerun this. Oh dear, where do we get?
It's because it's not equal to 0.
Yes, thank you. Equals 0 like that. Up here, run that. Then the value, the input list cannot be empty. So the value error is like, you should think of it as basically like the assert, but you can actually like pass some information right here. This information right here is what's going to appear to the right of the colon. So you can give the person a little bit more information about why it caused an error message. But value error and assert in practice used to do the same exact things. There's a good spot for us to stop, and we'll continue our discussion on exceptions and debugging on Wednesday. If anybody has questions about this or anything else, happy to stay after and chat with you about that.
Python tutors tell you to tutor, or do you have to do it on? Yes.
Python tutor should tell you the actual error message. Yeah.